As we press on in the world of moles and molecules, in this section we're going to look at how we go from mass to moles or molecules. Alright, so the formula weight is the sum of the atomic weights that are in a compound, and we report those in atomic mass units. You remember we use the periodic table for that. And so the first thing we have to be able to do is calculate the formula weight of a compound. Now, I know oxygen, if I look on the periodic table, oxygen's like 15.9999 AMUs. So that's what one oxygen, that's the mass of one oxygen. So if I have 4 oxygens, it's going to be 4 times that, right? So if I'm looking up the formula weight for this formula, FeSO4, then I'm going to write the formula, and then I'm going to figure out how many of each thing it has in there. So in FeSO4, I've got 1 iron, 1 sulfur, and 4 oxygen atoms. So that's important to get that first. Then I'm going to look up the AMUs for the atomic mass of each one of those elements, and I'm going to then multiply those by how many I have, and when I add them all up, it's going to give me the weight of the entire formula, or what we call the formula weight. So 1 iron molecule, atom, is times 55.85 AMUs, and that comes directly from your periodic table. 1 sulfur is 32.07, and then I had 4 oxygens, so 4 oxygens is times 16 AMUs is 64, 16 times 4, and then I add them all up, and so the formula weight for FeSO4 is 151.92 AMUs. When you're doing this, you want to keep your decimal places and your significant figures. So the molar mass is the mass of 1 mole of a substance. And the difference between the formula weight in AMUs and the molar mass is the fact that we know that there's a mole of those required. The number is going to be the same, but we report it in grams per mole. So molar mass is the mass of 1 mole of any substance reported in grams per mole, G per MOL. So when we look at the periodic table and we look at carbon, for example, carbon's atomic mass or atomic weight is 12.01 AMUs. And that's all well and good, but I can't do anything with 1 atom of carbon, which is 12.01 AMUs. What I can do something with, though, is 12 grams of carbon. So 12.01 grams per mole means that I can convert AMUs to grams. That's in the real world, right, from the microscopic world to the real world, by saying I have a mole of those. What does that mean, though? That means instead of 1 atom that has a weight of 12.01 AMUs, I have 6.02 times 10 to the 23rd atoms that weigh 12.01 grams. So 1 mole of carbon atoms weighs 12.01 grams. And so they're the same magnitude of number, it's just different units. So the molar mass is equal in value to the formula weight in AMUs. And you'll see people will use these interchangeably, and we'll talk about, so once we get past this AMU and talking about what the difference is, that it's a mole of it, which means you have 6.02 times 10 to the 23rd of them. Once we get past all that, you're just going to be using the molar mass. So molar mass relates the number of moles to the number of grams of a substance. So basically molar mass is another conversion factor, taking us from the world of the atom to the world of the real people, right? So the molar mass of H2O is 18.02 grams per mole, because H equals about 1 something times 2 is 2, and oxygen is 16 point something times 1 equals 16, so they give you 18 grams per, oops, sorry, per, when I get to the edge sometimes it gets a little crazy, per mole. So I can write that conversion factor as 1 mole over 18.02 grams of water, or I can say 18.02 grams of water per 1 mole. So all I do is I find the formula weight, and then it's in grams per mole instead of AMU. So let's look at an example. How many moles are present in 100 grams of aspirin? And aspirin is C9H8O4. Now, they've already going to tell you the molar mass of aspirin is 180.2. Now, we could do that, right? If we needed to figure that out, we'd say that we have 9 carbons times 12, okay, and we have 8 hydrogens times 1, and we have 4 oxygens times 16, and we could add, and then we could put these numbers and add them together, and then we would get that 180.2. That's where that came from. But they just gave it to us, so we wouldn't have to do it. Okay? So, and notice sometimes you'll see the mole without the E. That's fine. It's just a abbreviation. Okay? But they mean the same thing. All right, so we're going to identify what quantity do we have. Well, we got 100 grams of aspirin, and it wants to know how many moles are there. Okay, so we're going to go from grams of aspirin to moles of aspirin. So our conversion factor is going to be the molar mass of aspirin, and it told us that there are 180.02 grams of aspirin in 1 mole, or I could write it this way. All right, I know I'm starting with grams this time because it gave me 100 grams. So I know that I'm going to have to write this conversion factor. Why? Because grams will be on the bottom. Okay? So when I set that up, I set it up for grams to cancel. And so 100 grams times 1 mole of aspirin, which is really write that so I don't forget what it is, per 182 grams of aspirin, and those grams of aspirin will cancel, and then all I do is I multiply everything on the top, so 100 times 1, and then divided by everything on the bottom, divided by 180.2, and that gives me 0.555 moles of aspirin. And why do I have 0.555? I have 3 significant figures because that has a decimal. So it had 3 significant figures as well. We can also use this molar mass to show the relationship between grams and how many molecules we have. Because remember, if it's molar mass, that means that I have to have an Avogadro's number of those. I've got 6.02 times 10 to the 23rd. So I now have, in addition to 180.02 grams of aspirin per mole, I have 180.02 grams of aspirin per 6.02 times 10 to the 23rd molecules, because a mole of anything is equal to 6.02 times 10 to the 23rd molecules. So I can also use that to work these problems. So how many molecules are in 325 milligram tablet of aspirin if the molar mass of aspirin is 180.2 grams per mole? So I know that I'm going to be starting with my 325 milligrams of aspirin, and it wants me to know how many molecules are in that. I know that I have my conversion factors. Now, it gave me milligrams, so the first thing I'm probably going to want to do is convert those milligrams to grams. And I know that there are 1,000 milligrams in 1 gram. And I'm going to do that so that it will cancel, and then I'm going to get grams, and then I'm going to convert grams to moles and make sure that my grams will cancel and leave me with moles, and then finally I'm going to want molecules. So 325 milligrams of aspirin times 1 gram over 1,000 milligrams, because milligrams has to cancel, so milligrams would always go on the bottom because they're canceling these. That leaves me with grams up here. Alright, and so I'm wanting to know how many molecules. Remember, keep your eye on the prize, remember what you're going to. So 6.02 times 10 to the 23rd molecules is the same as a mole, also the same as 180.2 grams of aspirin. Alright, and so now I'm going to multiply 325 times 6.02 times 10 to the 23rd. Make sure that you're doing that correctly with your calculator. And then you're going to divide by 1,000 times 180.2. Make sure you're putting it in your calculator correctly. Make sure you try this calculation specifically and make sure you're getting 1.09 times 10 to the 21st. If you're not, you're probably not putting this in parentheses before you divide, or you're not putting this in the correct way in your calculator. So in your calculator, when you put this number in there, you're going to have to say 6.02, and if you have an EE button, just do that. 6.02 EE 23, or 6.02 times 10, and then there's a little cap 23. Alright, so if you're doing this though, you want to have this in parentheses and then multiply that by the 325. Then when you divide, make sure you can do it one of two ways. You can put in parentheses 1,000 times 180.2, or you can divide by 1,000 and then equal, and then divide by 180.2 and equal. You can just do them separately instead of putting them in parentheses. You can do it either way.